signals. So one small problem we will do. The circuit is given. See, R1 is 40K, R2 is 4.7, RC is 4K, RE is 1.2, VCC is 16. Other capacitance are not required because we don't use them for H parameter analysis. This is just given for the design perspective. Okay. And input impedance, see the formula for input impedance, ZI equal to E. Okay, and first you compute RB. RB is R1 parallel to R2, 40K parallel to 4.7K. The answer come to 4.2. With that, once again you do HIE. HIE is given in the question 3.2K. So ZI equal to 4.2 parallel to 3.2, it is 1.82 kilo ohms. You can see in this bias, the input impedance is reducing, which is not a very good sign, because when the input impedance is reducing, the amplifier tries to draw more current from the source, which is a sign of danger, because if the amplifier tries to draw more current from the source, two things may happen. One is either the source will be unstable. Second thing, when enormous base current is flowing into your transistor, the breakdown might happen, because your base cannot withstand so much enormous amount of current. And output impedance, it is equal to RC, and RC value is 4K, so Z not equal to 4K. Okay. And when you find the voltage gain, see, I am using all the formulas directly because we have derived these formulas in fixed voltage divider bias concept. Voltage gain AV equal to minus HFE into RC by HIE. HFE is given 100, RC is given 4K, HIE we have computed 3. HIE is given in the question 3.2K. When you substitute, you get the voltage gain as minus 125. And current gain formula minus HFE into RB by RB plus HIE, you get minus 56.76. Direct substitution into the formulas. If they ask power gain in the question, in case if they ask what is the power gain, can anybody say what is the formula for power gain for this common emitter amplifier? What is the formula for power gain? Knowing AV and AI, how will you find power gain? Can anybody say the answer? What is AP when they ask power gain in the question? What is the expression for power gain? What is the formula for power? Generally, what is the formula for power? Power equal to nobody is there in the class. Power equal to what? What is the formula for power?
I into U.
Yes. So what is the formula for power gain? Knowing the voltage gain and current gain. So power gain will be equal to voltage gain into current gain. So you need not compute power gain separately. It is product of voltage gain and current gain. And one unique thing you will find, see, voltage gain is negative, current gain is also negative, but power gain will be positive, because you don't have the concept of negative power, right? So even though voltage gain and current gain are negative, power gain will always be positive. So it is 125 into 56.76 is your power gain. So you can see enormous amount of power gain is provided by the common emitter amplifier. Okay, so this will conclude the concept of common emitter amplifier analysis using H parameter model. So we have analyzed fixed bias circuit. We have analyzed a common circuit with unbypassed resistor, fixed bias plus unbypassed resistor. Now we have analyzed voltage divider bias, common emitter amplifier. Again, theory we have derived all the formulas. If any problem comes, you have to remember the formulas, and direct substitution of the values will give you the answer for all the 4 parameters. Remember, we'll find all the 4 parameters only for all the common emitter amplifiers: input impedance, output impedance, voltage gain, current gain. In case power gain is asked, power gain equal to voltage gain into current gain. Sometimes they refer it as input resistance, sometimes they refer it as input impedance. Everything is same. We need not worry about the question which is asked with respect to input resistance or input impedance. It is all same. Okay, so with this we complete common emitter amplifier analysis using H parameter model. We have so far we have seen all single stage amplifier, only one circuit we have seen, right? So now next we are going to see what is called as multi-stage amplifiers.